So we've got entry task 2. We're actually giving this as homework today. So we're going to run through this one together. And what we've got is we have point A located at negative 5, 3. Point B at 0, 6. Point C at 5, 3. And point D at 0, 0. So I'm going to connect those points to form a quadrilateral. And now we've got the issue of having to find side lengths. So I'm going to go ahead and use the Pythagorean theorem to do that. And so I have a height of this triangle of 3, and it's 5 across. And then for this triangle, I see that I have 3 and 5 again. And for this triangle, I see 3, and 5. And again, for this triangle, I see 3 and 5. So I know that all those side lengths are going to be the same because the two legs of each triangle are the same size, and so I only need to do the Pythagorean theorem once in this case to figure that out. And so I'll do a squared plus b squared equals c squared. And I've got 3 squared plus 5 squared equals c squared, which gives me 9 plus 25 equals c squared. And that's 34 equals c squared. So we're going to have the square root of 34 equal to c. And so on my calculator over here on the side, I'm going to run that really quick. And I get 5.83. Now again, each one of these sides is going to be the same length because the triangle that I was able to attach to the side has the same lengths of legs. So this is all 5.83. And then the slope of each of the segments. And so for AB, I should probably label my points. And so there's A, up here is B, over here is C, down here is D. For AB, we have a slope of 3 over 5 because we went up 3 and to the right 5, so it's a positive slope. From B to C, we went down 3 and to the right 5, and so that's a negative slope. And then CD, we went up 3 and to the right 5, so that's a positive slope. And then AD, we are going to go down 3 and to the right 5, and so that's a negative slope. And so asking ourselves the question, are there any parallel or perpendicular line segments based on the slopes? The answer is yes. I have AB being parallel to CD because their slopes are the same. And I also have AD being parallel to BC because their slopes are the same. And so we do have parallel lines. Do we have any perpendicular lines? The answer to that is, and if we look at the first one at 3 over 5, to determine that, look at AB. We have 3 over 5. We would need, for something to be perpendicular to that, the opposite reciprocal slope. So we'd be looking for a slope of negative 5 over 3 because that's the opposite reciprocal. And I can see that I do not have any slopes that are the opposite reciprocal. So I do not have any perpendicular lines. I do have sides that are parallel, and all the sides are the same length. And so if I did have perpendicular lines, this would be a square. Because I don't have perpendicular lines, this is going to be a rhombus. Because I have opposite sides are parallel, and opposite sides are the same length. And I have no perpendicular lines. So it's not a square. That makes this figure a rhombus. And that's going to be it for this homework assignment. I hope this video is helpful, and I hope you have an awesome day.